All right, just going to make a really quick video. Last week we did the calorimetry, where if you stick a hot metal into water, and then you could see how much the water increases in temperature, and knowing the specific heat of water, you can do some calculations and you can identify what type of metal that was. So that was with the calorimetry. This is now enthalpy. So it's not like the transfer of heat between two substances or two objects. It's now the heat energy change in a chemical reaction. So we're going to look at two different types of chemical reactions. First one's called endothermic reaction. This is where heat from the surroundings is absorbed. So these are reactions that absorb heat energy. So their enthalpy or their delta H is going to be positive because energy was absorbed. Energy was added to what's called the system. The chemical reaction added more energy. The other one is called an exothermic reaction, and that's what's going to release energy in the form of heat. So this is where energy is being released to the surroundings, released to the environment, and therefore the system, the chemical reaction lost energy, so its enthalpy value will be negative. All right, so here is a exothermic reaction which release heat. So the surroundings will get warmer because heat energy is being released by the system, by the chemical reaction is releasing heat. The delta H, the enthalpy, is going to be negative because heat energy is released. So the system, the chemical reaction, lost energy to the environment, to the surroundings. So energy got released. Therefore, the delta H, the enthalpy value, is going to be negative. It's not going to be positive. It's going to be negative. So you can see here, you're not going to have to do any of these calculations, but you're going to have to be able to read a graph and be able to determine if it's exothermic or endothermic. So here's the energy of the reactants, the things that go into a chemical reaction. You see how high up it is. Here's the what's called the activation energy. So this is the energy required to get the chemical reaction started. So it does require some activation energy. And then here's the chemical reaction right here. So blue is the activation energy. Red is the energy that gets released. So you can see the energy of the reactants is more than the energy of the products because the products is down here. The products is lower. Products is lower in energy because energy was released in the form of heat. So this would be an exothermic reaction because the energy of the reactants is higher than the energy of the products. Energy was lost, and that's why it's going to have a negative delta H or negative enthalpy. All right, now here's an endothermic reaction, the opposite of exothermic. These are ones that don't release heat to the surroundings, but they absorb heat from the surroundings. So it's going to take heat from the surroundings and add it into the system, add it to the chemical reaction. So the surroundings will get colder. So if you have an ice pack that you like crunch up and then you shake it up and it turns really cold, that would be an endothermic reaction that's occurring inside that bag. All right, so this time the delta H, the enthalpy, is going to be positive because it's adding energy from the surroundings into the system. So the amount of energy into the system in the chemical reaction is going up. That's why it's positive. So it's absorbing heat energy from the surroundings. So the products are going to have more energy than the reactants. So once again, here's the graph. So this time it's going to be different. So this is an endothermic reaction. You can see the reactants down here. Remember, the reactants are what goes into a chemical reaction. Products are what comes out. Here's the activation energy, the energy required to get the chemical reaction started. But then you can see the products end up here. Now the products are higher up in energy than the reactants. So energy was not released, energy was absorbed in this endothermic reaction. So you're going to have to be able to look at a graph and be able to describe, is it endothermic or is it exothermic? All right, so I skipped some slides. A lot of them, it's just reading. I'm not just going to read them to you. You can read them. You guys are good at reading. All right. So, anyways, another thing you'll need to know: these things are on our final exam. So I did look at it. One thing that's on our final exam is a catalyst. It's a substance that speeds up a chemical reaction without being used up. You won't need to know that, but it works by providing an alternate pathway. But what you need to know, it requires less activation energy. So you can see this energy diagram over here on the right. So you can see the reactants right here in blue. You can see the products down here. Oh, energy. The energy of the products is less than the energy of the reactants. So this exothermic or is this endothermic? Since the energy went down, it released energy to the surroundings. This would be an exothermic reaction. But what we want to see here is without a catalyst. So you can see the activation energy required without a catalyst requires a lot of activation energy to get the chemical reaction started. With the catalyst, with the substance that's going to speed up the chemical reaction, it reduces the amount of activation energy required. So it requires much less activation energy. Therefore, the chemical reaction is going to happen much faster. All right, so that's a catalyst. And remember, this would be exothermic because the energy in the reactants is higher than the energy of the product. So energy was released from the system into the surroundings. All right, so do your best on these notes and our worksheets, and I'll see you hopefully later this week.